Looks like we have a little commercial property to go take a look at next. Just looking at the address, it's probably a little Butler building, maybe in a little warehouse community, but we'll take a look at it and see what we can figure out. The tenants are essentially just saying that the system doesn't appear to be keeping up very well. If memory serves, it is likely a Butler building, and being 90 some odd degrees outside, it may be having trouble keeping up, but could be any number of things, from just doing the best it can in the situation it's in to actually having a problem. But we'll stop by and see if we can figure something out for them. All right, we can hear that is the contactor likely buzzing in there. So either we have no power or there's a problem with the contactor. Normally you wouldn't hear the contactors humming just because the compressor and fan motor are running. So let's crack this guy open and see what we see. All right, we'll check and see if we have power here. So we do have line voltage, and across the contact points here we'll check, and I'm also showing 208 volts, which tells me even though our contactor is making, we can hear it vibrating. We'll just double check, make sure. So we do have 24 volts there. So our contactor is pulled in. It is trying to energize the system, but we're not getting power across these contact points. So let's disconnect the battery. Let's disconnect the power here and see if we can get a screwdriver in there. It looks like somebody's already pulled this off once before. So one screw is missing. So our contacts are indeed pulled in. And from this angle it's hard to tell if we have any damage there. We'll try one more time since we have our contact down. So no continuity through it. We can see our contacts are actually pulled in. So let's replace this contactor. So our control contactor is a pretty simple device, really. We have an electromagnet down here with a little plunger attached to our contact points that we saw over here on this one. So when you apply power, our Y essentially, so we have Y on one side, common on the other. When power is applied, it energizes this magnet, pulls our plunger down, and brings our contacts in contact with our main power coming in, our L1, and it passes it across to the other side, energizes the system. So you can kind of think of them as electronically actuated light switches, I guess. So essentially our Y comes in, hey, want the unit to activate, depending on whether all our pressure switches and everything are set and our timing on our particular board, then it will energize and apply that 24 volts to our contactor with a common. Snap it in, energize the system, and there we go. In this particular case, our contact points are damaged, so it's not actually allowing voltage to pass through. So we'll replace this guy and it should be good to go. Trick that helps, you can use a flat bladed screwdriver to pop these spade clips off the terminals. Just makes it look easier sometimes. So first we have our common to our fan, or our L2, our common going to our capacitor, so they're both on the same side essentially. And we have our L1 to our fan that runs through the defrost board relay for the fan control. The contactor we're using has a different terminal setup than the existing one, so we're clipping loose the compressor leads for run and common on the compressor. We're going to strip them back a little bit and use the screw-in terminals on the new contactor to secure them in place. Next, we just need to disconnect the low voltage on Linux units. Typically, their Defrost board controls the control contactor individually, so our low voltage comes in the right-hand side. Depending on how the pressure safeties and temperature safeties work out, it will either energize or not, or depending on short cycle delay, the control contactor through Y out on the left-hand side. That one snapped in, and it's not nearly as loud, so that's another sign we probably had an issue going on. And as this one popped open, I can actually see damage to the contact points in there. But as you'll notice, it's always easier, and the way I tend to do it, because again, Jarrett does not like to think when he doesn't have to. So a lot of times it's easier to do these in such a way that if we disconnect one wire at a time, we don't have to worry about forgetting which side to put things on. These are easy enough, honestly. I can pretty much just look at it and know which wire went where, so I mess with them so often. But especially if you've never done it before, easiest way to do it is to just pull the old contactor loose and then take one wire off at a time and put it back in a similar spot on your new contactor, so that way you don't get confused, especially when these things have been worked on frequently. This one's not a good example of that. It's a relatively new unit. I say relatively new, it looks to be about 2016, but in good condition, hasn't been modified much, but you can easily come up across some of these units where it's been interestingly repaired as far as wiring goes, where someone just used whatever happened to be in the truck at the time. So you'll have 15 different wire colors or the same wire color for everything. Rather than have to trace all that out, a lot of times it's easier just to do one wire at a time and be done with it. Alright, so easy enough. So now for the moment of truth. Oh, that's the one behind us. Here we go. So everything was happy, and it was just simply a bad set of contact points in there. Not too bad for troubleshooting on that particular one. Contactors do buzz a little bit just in their nature. They are essentially an electromagnet pulling a plunger down to push some contacts into place to pass voltage through them. So you're just using low voltage to actuate a magnet to apply high voltage. So you can get a little magnetic resonance or buzzing through them. However, typically the compressor sounds, the condenser fan operation, and refrigerant running through the line, you don't really hear that. That one was a little excessive in the amount of noise it was making, so pretty much immediately thought, it's probably a bad contactor. Went ahead and checked though, because I have seen some that loud or louder that nothing is actually wrong with the contactor. It's just a very loud contactor. This particular case did have 208 volts supplied. As we checked across the contact points that we knew were engaged or should be engaged, we also saw 208 volts. So that is also something to keep in mind, that your meter is not magic. It's literally just almost a calculator. It's measuring the difference between 2 points on your meter, literally the two things you're holding. So if you see a 0, does not mean you necessarily have 0 volts. It just means that there is no difference between the electrical potential on each side. That's why you'll see me sometimes check it and then touch one side to ground, because I'm trying to see whether it's actually powered or no power at all kind of situation. So something to keep in mind, but if we were to have seen 0 volts on that connection, hey, we should be running. Need to look somewhere else, maybe a disconnected wire farther up in the unit, maybe a bad capacitor. This particular case we saw 208 volts, so we knew we were not getting any power through that contact. Upon pulling the cover off, we did see it was bad contacts. It looked like somebody had actually already looked at it. One of the screws was out, so I don't know if someone messed with it previously, possibly tried to clean it out. May have worked for a little while, but in this particular case it was no longer operational. Changing the contactor, not a big deal. I am simple-minded, so I like to do things the easy way, so I don't have to think about it. I just pull it loose, mount my new contactor, and just do wire for wire. That way nothing gets confused. Not very hard to figure out, honestly, especially on that one, being that it was in relatively good shape for its age, had not been operated on much. But you can easily come across these things where, you know, had a problem inside, burned up a bunch of wire, whatever technician worked on it, they only had a handful of red wire or something like that. So now suddenly you have 53 red wires and scratch your head thinking, where did that go? So usually it's just easier to do it that way, at least as far as my line of thinking goes. But all in all, got them cooling, and we'll move along to the next one.